voice be okay? All right, so this is what a hyperbola is. Feel free to stop the movie and write all this down for anyone that's absent or whatever. But it's the distance subtracted. Obviously, the bigger distance minus the smaller. I guess if you went smaller minus bigger, you just have a negative same number, so it doesn't matter. I don't really need to know that, but it is kind of interesting. And I'm going to go further on this. I'm going to show you some things that I investigated yesterday because I knew of certain things that existed. And I wanted to show you ahead of time. I'm going to show you something, an interesting picture through a news story that I just heard. I'm going to close that so we don't see her. I think I just closed everything now. All right, so now I have to open up. Oh, no, I didn't. Okay. So I get to do that. Oh, I did. I lost all my. Hmm. Yeah, I'm struggling. So let me see. Open up a new. Oh, boy. I just screwed myself up because I closed all my websites. So look at that. Star Teacher. How do I open up another window? Goodness gracious. New window. There we go. Goodness gracious. That was tough. Samuel is struggling with the internet again. It's always so much fun. And then I need one more thing. I think I'm in the way. There it is. Okay, two things. I want you to really pay attention to this. This is pretty awesome. Boom. Number one, this article explains, and I'm in the way again. You know what? I'm just getting rid of myself. Boom. Planet Nine. This is awesome, actually. The show that I showed you before, Space's Deepest Secrets, is either in that one or How the Universe Works. Or I watch many different shows. But there, even like 4 or 5 years ago, there was a show dedicated for 1 hour about Planet Nine. Statistically, through how they are observing how objects are behaving out in the outer skirts of our solar system, they firmly believe with a high, what is this thing down here? With a high amount of probability using statistics that there's a planet out there 9 times the size of Earth. I find that fascinating. And then lo and behold, just yesterday or today, another story came out about data that somebody looked at that was 38 years old, applied some statistics to that data, and actually we're getting closer to thinking that this is, really a reality. The probability went higher that this is true. But I love this picture. Look at all these orbits. These are orbits of like probably comets and other things and other objects that we know that we track. Anyone ever hear of Halley's Comet? Halley's Comet. Good. Because we're like right in the middle of the last time that it came through our solar system. I was a freshman in high school. It was 1986. Halley's Comet came through. And I looked at Halley's Comet trajectory and it was like this. Now, you know what this is comparable to? Like our orbits, like I think this is, I don't know what that is. I think this is supposed to be the sun. Yeah. Our orbit's like this big. It's like that small comparative to these orbits of these other objects that we know. And Halley's Comet is that crazy as well. Very elliptical, and it shoots way out to the outer outskirts of our solar system. So Halley's Comet, the next time it's coming is 2061. I'll be 90 years old, and you guys will be whatever. You'll be in your 50s, and that's the next time it comes. And I remember when it came, it was very bright, and I think you could see it a little bit during the day. Anyone hear about the moon last night? Anyone hear about the moon? The super orange, and it had an eclipse on it. Did anyone watch it? You have to wake up at 3:34 in the morning. Somebody watch it? Oh, I was to say if you did, because it was super clear too. My radio guy in the morning, he comes in at 3:30 in the morning, said it was awesome. It was like super bright, super orange, and you could see the eclipse. So pretty neat there, a different story there. But Haley's Comet, I want to tell you the story, and I don't really care. But that has nothing to do with what we're learning today. It's called Haley's Comet because of the scientist, Haley, who I hope I don't have my wires crossed. That's definitely from the show Cosmos. Haley was a very good friend of Isaac Newton. And actually, Haley got Isaac Newton out of his reclusiveness to actually do the many things that we you know today because of this amazing scientist. And Haley was no slouch himself. He did a lot of really powerful things. The one thing he did was he did some research, and he researched ancient data. But the data was that in certain societies, they would talk about this thing in the sky, and the older it went, people were more like cave people, like scared when the thunder hit. That meant the gods were angry. They'd run in their caves and hide. You know, we were very superstitious, and I think we are still a little too much this day. We should be more intelligent in how we approach things as a race, I believe. But back in the day, it was way worse. But he surmised that this thing in the sky that was a harbinger of doom was a comet, and he kept looking at the data over different societies over these spans and noticed there was a commonality that they were about 76 years apart through all the things that he did. So we made a prediction, the first person ever to do this, and say, I think this is a comet, and I think it's coming at this time. And it was many years in the future from where he lived. Unfortunately, if I remember correctly, he died before he got to see that he was actually 100% correct. The first person to ever do that. So that's why to this day we call that Halley's Comet, the comet that he predicted was going to come at the time that it came, within a very precise time period as well. So that's why we know our comet is coming. Now we have more precise instruments, of course. And I forget what the date is, but there's actually a specific date that we know that this comet's coming back. Very interesting. And this guy did this with very minimal instruments, just using a scientific method to get this to go. So look at these orbits, super duper elliptical. And then why did they surmise there's a planet nine? Because of gravitational pull. The way these objects are acting, there's got to be a body out there that explains how these objects are acting. That's the point of that. That's the use of statistics. Neptune. Neptune was proven statistically and through probability that it existed before anyone ever saw it. Same reasoning. Just the way our planets were acting, there had to be another planet out there for our orbits to be holding the way they were. And then years later, we proved it by sight through a telescope. So pretty cool stuff when you think about that. And then I can open up my other one. And then I opened this up, and I was thinking about, because I said some things like orbits could be elliptical or parabolic or today hyperbolic. And it's actually true. So I looked at a Wikipedia page. I guess this is what this is. I want you to think about that. Our orbits are elliptical. And then there was something in this article that you guys can now understand a little bit. They talk about eccentricity. And they actually said if they can calculate the eccentricity of an orbit, they'll know if it's elliptical, parabolic, or hyperbolic, right? Elliptical, the eccentricity, just like the ones that we found, it's in this article, is less than 1, which is what you got for eccentricities for ellipses. This was interesting, and I don't quite get it, but they said when the eccentricity equals 1, then it's a parabolic orbit. And then if it's greater than 1, it's a hyperbolic path. I want you to think about parabolic and hyperbolic with something I shared with you earlier, and I have a shirt for it. It was the Voyager mission. You remember that? Remember I told you about the Voyager, my shirt that I have for it? And it was a mathematician that solved how to get there, not an astrophysicist. These orbits, parabolic and hyperbolic, is that method that mathematician found out how to do slingshotting, using satellites and using the gravity of a planet to slingshot off of it and keep continuing out into space. That's these two orbits right here, slingshotting of our satellites to throw it out into deeper space at a faster speed. So two interesting things there that are completely relevant to the things that we're finding here. So anyway, moving on. Here's what we're actually going to have for a graph. Now this one I do want you to write. Here's how we're going to graph it on a coordinate plane. Boom shakalaka. A lot of stuff to set up here. And then at the end of this is going to be super easy when you do your homework. It really should be, right? Because it's not far off from graphing an ellipse. I want you to notice some things in the equation, which I have not shown you yet. So I got to zoom in on this. It's a little, I guess the picture I took of the notes here got a little blurry. First of all, notice the difference in the equation. The equation, no pun intended, notice the difference? There's a difference. Do you see that? So that's how hyperbolas stick out like a sore thumb. One of the squared terms has a minus sign on it. Now, I'm going to go back up to that picture in a minute, and you can feel free to do those letters, but never think about the letters again. It's not about the letters. It's not about who's A, who's B, what's going on. It's all about radii. It's all about the radius, the x-axis and y. So let me go to the equation real quick and put that below here and leave some room to hack it apart. This is the way I look at hyperbolas. And now think about your parabola folder. Listen, what's a parabola? That's an x squared. Which way does it go? What are our possibilities? Up or down? This is not what happens with a hyperbola. This is what happens when we get to hyperbolas. Then students mix up their parabola and hyperbola folder. All right, I'm talking about folder like your folder in your brain. What I do is I call this good axis. I always think as positive good, negative bad. And this is actually called, this was up in your thing up there, transverse axis. That's our term for the day. The good axis is the transverse axis. So when I look at it this way, oh, and I'm going to do this. Minus, bad. Bad, minus is negative. That's actually called, you don't have this word up there, the conjugate axis. And then that's a word you already have, but it has a completely different meaning. That sometimes happens when words mean something else. The minus means the bad axis. So this is an x squared. X is the good axis. This is a hyperbola that goes right and left. Got it? Then I'm going to move over to the other side and show you when we switch the good axis and bad axis and talk about these dotted lines. I actually threw a word out first hour and I forgot that you never heard of this word before in your life. So I'm going to make sure that I define something for you. You're not falling asleep, are you? You look bored. You don't like space, do you? I grew up in an era that space was fascinating. I had movies like Close Encounters of the Third Kind. Anyone ever see that movie? I made my kids watch that. Close Encounters of the Third Time. Obviously, Star Wars, Star Trek. Space was like a really big deal in the 70s and 80s. It was a really cool era. Carl Sagan was like a rock star as a science. I'm not kidding. As a scientist. Anyone know Neil deGrasse Tyson? You better at least know him, somebody. Neil deGrasse Tyson only is who he is because of Carl Sagan. He met Carl Sagan as a teenager. But what Neil deGrasse Tyson is, Carl Sagan was 100 times that as far as popularity. And I wish it was still like that. It was really kind of a neat era. And then now we got an up downer. So again, here's what I did with the other hour. I went like this. I said highlight, note taking purposes, good axis. All right. Well, now the good axis is the y axis. All right. So that's why this changes. And then I put blue as bad. So this is the bad axis. So I need this to go up and down along the y axis. Completely different because a y squared parabola goes right and left. So if you can get that, like this opposite thing going on, then you might be okay. And I hope you didn't screw that up yesterday, because if you screw that in parabolas, the parabola is destroyed. That's the very first thing that you need to know. All right, then I'll show this picture. There's your difference there. And now's the time to talk about how do you graph it, which is almost exactly the same as an ellipse, but you stop and don't draw an ellipse. You do get your y-axis radius, and you go up and down that. That's why this says 0, comma A. And I'll talk about A and B. Forget about A and B. Don't care who's A and who's B. There's only one time you really got to be careful. A does not have to be bigger than B. As a matter of fact, in this picture, doesn't it look like A is smaller than B, right? Look at the box. You see that? Yes? Can someone shake their head that they exist in my class and have some understanding? Thank you. All right? So A does not have to be bigger than B. A is just the good axis radius. That's it. Doesn't have to be bigger. All right? I still do my x-axis radius, but then I stop. And then you can see what you draw. You don't draw an ellipse, you draw a box. And then you draw these mysterious lines through the corners of the box and the center. And then it looks like I draw my hyperbola. Notice I said hyperbola 1, hyperbola, where it looks like the hyperbola is approaching these lines but not crossing them. So this dotted line is called, are you ready? It sounds like a naughty word. An asymptote. Whoa, Mr. Samuelis. An asymptote. And you're going to see these a lot next year. I can't really think if we're going to see them again this year. With the topics that we have, I don't think we do. This is an imaginary line. Not like an imaginary number, but a line that we write that just helps us do something. So it's an imaginary line. In this case, it's a line. Asymptotes could be quadratic, cubic. It's actually interesting. Quadratic, it could be like a parabola, but it's an imaginary line that a graph approaches. Now, I want to say and never crosses, but sometimes they can be crossed. So that's kind of like a bad definition. But that's really what this is doing. This graph is approaching that dotted line, so it controls the shape of that graph. Controls shape of graph. And that's another reason why this is a little bit different than a parabola. Parabolas do not have asymptotes at all, where the end behavior is way different for a hyperbola, way different than a parabola. But it looks like a parabola right at the start. Okay, and then notice this. We'll stick with this one. We're calling this A from here to here, and this is definitely C, just like in an ellipse. What is C compared to A then now? Bigger or smaller? 3, 2, 1, go. Bigger. What do you think your formula is going to be for C squared? Do you think it's going to be A squared minus B squared? Yes or no? What is it going to be? Plus. The reason it has to be bigger, C is like a focus. No, I'm sorry, it is a focus. Serial, say it. Full stop. There is no table, right? There is no table. But this is a bowl, and it must be in the bowl. The only way that it could be in the bowl is if C is bigger than A. Same thing with this other one over here. Here's C. I'm sorry. Here's A when you're going right left. Here's C. Yet again, C's got to be bigger than A. All right. That's how the cereal gets in the bowl in this case, as far as how you move. All right. So giving you some good stuff there. Oh, and then I have one more thing. What's the equation of these two dotted lines, which are called the asymptotes? What's slope? What two R's are there for slope? What two R's? R over R. 3, 2, 1, go. Rise over run. If you start doing A, B, B over A, and then you get all confused, which one is it? Flipping coins, you're going to get destroyed. This is simple. For this slope, it's the y-axis radius over the x-axis radius. In this case, this was B over A. Again, I couldn't care less about B and A. A is the radius of the good axis. B is the radius of the bad axis. But in this one, it's A over B because the y-axis radius is the good axis. A over B, B over A. Stop it. The actual slope of the asymptotes is rise over run, which equals y-axis radius over x-axis radius. I got to finish that. Rad. I'll put the whole word radius in this one. Oh my gosh, there goes my pen. Jacking around with me here. Oh my gosh, still messing with me. Let's put rad for this. Can't say I'm doing the notes too fast. That took me forever just to get that taken care of. So don't be doing B's and A's and B's. That's robotic formula stuff. And I admitted to my class first hour that when I taught this back in the 90s with at Providence Catholic High School, I was learn and memorize these charts with A's, B's, C's, and know when to put what where. And I did that for parabolas, ellipses, hyperbolas. And then we got to the test and it was a disaster because it was an overload. It was too much information to approach that way, formulaic robotically. So that's why I've done what I've done over the years, what we're doing here. And I really hope you appreciate it, but you can't make everyone happy, I guess. All right, so again, those terms come up and I have them in writing now. So A is the distance from the center to the vertex, which is a radius. And I do like the word vertices or vertex here. These are vertices. These are vertexes. These are vertexes of something that kind of looks parabolic. All right, so that is a good term there. And then I did give you that other thing. Bad axis is conjugate axis. These are just radii values. And yet again, C finds the focus. C finds the focus. Then I'll zoom back, and then you can see for the hyperbola formula that you already surmised. It's not a squared minus b squared. C's got to be bigger than a. It's a squared plus b squared. I get infinitely sad those that crisscross these two formulas between ellipses and hyperbolas. They've listened to nothing that I've said about what happens with an ellipse and the foci. Foci have to be on the inside. What happens with the foci here? They have to be on the outside. They have to be in the bowls. All right, then I'm going to zoom back and show it all if you want. And transverse axis length, I mean, that's simple. It just connects the vertices. So what's the length? It's just 2 times whatever the radii is. What's the length of the conjugate axis? 2 times whatever the radius is for the bad axis. Foci land, of course, on the good axis. How could they not? You got to be in the bowls. And then this last thing that it says here that we surmised already. For an ellipse, A has to be bigger than C. So the foci are inside the bowl, inside the ellipse. For a hyperbola, C is got to be bigger than A, so it is in the bowls. There's more applications to space for hyperbolas and ellipses. You just happen to have a math teacher that loves space and watches all those shows religiously. I kind of lost touch for a while because I got a new TV system and I lost all my DVRs. I DVR'd like all those shows and I'd rewatch them over and over again. And now I lost them and I haven't really investigated trying to see them again. I haven't seen a space show in a long time. Not that anyone cares, but I'm obsessed with Columbo right now. Anyone ever hear of Columbo? I'd be amazed if he did. It's a great murder mystery guy. And the point of that show was you'd see the murder at the beginning, so you knew exactly what happened. But the whole show was about how Columbo actually solves the crime. And he's persistent and he's a genius, but he plays off as aloof. And it's actually a really cool show. One of the coolest characters ever on TV, and nobody in our generation, your generation, probably even knows about him. Okay, so yeah, it just says this again, good axis, bad axis. When the x squared term in the equation is positive, transverse axis is the x-axis. When y squared is positive, y-axis. Good axis, bad axis. I already told you that, so it's a reiteration. However you want to get it down, you figure it out. And then our examples will be fast. The setup for this is a lot longer than what your homework's going to be, but I think this is what you should know as you go into something. Where does the stuff come from? Where is it at in our world? And then, going from there. Wonder how I sound on this microphone with my voice as it is. Actually, it feels like a little better right now. So, getting in the swing of things. All right, let's actually do a thing. And then we'll see how ridiculously fast the math is after all that stuff. Now, why don't we put stuff on a piece of paper? Well, look at the website I just showed you. It was a piece of paper on a two-dimensional surface trying to get you to understand orbits. So everything that we do and we plan it on a piece of paper or on a flat computer screen. And we coordinatize the world. And then through that coordinatized world, we put that hyperbolic motion on there with an equation that describes it. So that's the point of like all of this, why you are doing this training mathematically. So you have at least an option when you go to college for some opportunities in anything you decide. But we do all these classes. Argument for education. What do I do first on this question? What do I do? Can't equal 16, so what do I do? You had one like this on your quiz yesterday. I shouldn't say that. We still got people that haven't taken it. I wasn't ready to graph. You got to do this. And we should have known that. And hopefully we did. Now I can do my x-axis radius. And this is A. Notice right off the bat, A does not have to be bigger than B. That is not an indication. It's good axis, bad axis. So this is the good axis. Good. So I'm going along the x. Don't screw up parabolas now. It's the third time I've said that. 1, 2, and I'm speaking from experience of grading. This is what happens. We go to hyperbolas and then our parabola folder gets all jacked up. Go up 4 and down 4. I really hope you had that parabolas down on the test because that's a disaster if you didn't have x squareds going up, down, y squareds going right, left. You get all those wrong, especially the multiple choice. That's precision. That separates the A's from probably the C's. I mean, that's a big problem if you didn't get that down. But you don't draw an ellipse, you draw a box. So good axis, these are the vertices, and I will mark them as such. And then this is what you keep doing. You don't even draw yet. You got to draw your asymptotes next. You got to get your graph to have shape. So through the corners of the box in the center. And then you can draw these what look like parabolas, but they're not. They're being controlled at the end by those asymptotes. So it approaches those, but does not cross. So drawing this is not hard. It really isn't at all. Piece of cake as long as you get all your stuff taken care of. I'm going to do this real quick. C squared equals A squared plus B squared. Pen's being a jerk. C squared equals 16 plus 4, which is 20. And then you're going to square root it. And I'm not covering this like explaining it. 20 is 4 times 5. If you still can't do a radical, you're severely and totally behind in this class. Like way behind. Square root of 4 is 2. So 2 root 5. All right, so now we're going to look at our stuff. Vertices, which are the endpoints. I guess I'll write this down. Endpoints. I'm really going to caveman it here. Endpoints of the transverse. Struggle in writing. That's not the pen. My brain. Oh, and I just did an M instead of an N. Transverse axis could be another thing that we say for that. That is plus or minus 2 comma 0. No coordinate, no points. I don't think they're called. I've never heard them called covertices. These are called the endpoints of the conjugate axis, and those are 0 comma plus or minus 4. The y-axis radius move. Not vertices at all. That's why they're not called covertices. My bad. It's not even part of the graph, but it helps draw my box to draw the asymptotes. That's the only thing, to determine shape. Vertices, foci. Now I can do the foci real easy. The foci go right, left. By the way, the square root of 20 is 4 point something. Square root of 16 is 4. Square root of 25 is 5. So square root of 20 is 1, 2, 3, 4 point something. 1, 2. So a little x there, and then 1, 2, and a little x there. All right, I like doing that as that. Those are the serial pieces. All right, but I went right, left as the point. So it's plus minus 2 root 5 comma 0 for the foci. One more thing I got to do is an eccentricity, but asymptotes. B over A over B, baloney. Neither. What are the two R's, everybody? Rise over what? Run. You can't see my picture anymore because I was in the way, but basically, what do I do from here to go from this point to this point? I have to rise 3 and then run 2. Or I have to rise 3 and run 2 this way, which is a negative move. That is why the asymptotes will be y equals plus minus. I'm sorry, not 3, 4. 4 over 2 is 2. So we do them both in one shot. Y equals plus or minus 2x. Y equals mx plus b. What is b? What is the y-intercept for both of these asymptotes? What's the y-intercept? 0. That's why I don't write a number for that. It's just that slope. Okay, let's move on because I have to complete the square after this too. And do a couple more, and I got to go fast now. This is how fast your homework's going to be. By the way, it'll be a silly fool if you don't do what? And I really question that. Some people turned in their homework. There was no drawings on that section. I firmly believe you cheated. All right? I firmly believe you just took the answers off the sheet. And that's still happening, I think. And you guys are charlatans, only causing your own demise. And this is why I still have people getting 25% on tests. My only explanation. So I'm not sure what's going on, why some of us have not made that change. But anyway, foci are 8, 0 and negative 8, 0. I can't even do this without making a quick sketch. I just got to get all my parts in where they belong, and then I can let my brain kick in with the file that I have for hyperbolas. Your file's just starting. How are you doing these without drawing a picture? Bologna sausage. There's no way. Okay, so these are vertices. All right, I got it. This is me thinking to myself. And these are foci. So absolutely, which way does this have to be going? Right, left, or up, down? 3, 2, 1, go. Right, left. So right off the bat, I know it's an x squared minus a y squared. All right, and then right away, I know that this is my a value. And this is my c value, because that's what happens. Or this is the x-axis radius. So 5 squared goes underneath here. So I'm already halfway there. It really only had 2 parts. And then just really think about this, how Monday is going to be so easy. We're just going to change the center. Obviously, from ellipses, we know that this is a center of 0, 0. So everything is based off of 0, 0. On Monday, we're going to put H and K's. Ain't a big deal. Everything's based off of H of K, H and K. We should have actually done it today. But I like all the other things that I set up here to get you to understand some stuff. Right? And then now I can bridge the gap between all these letters through our magic formula. So this is 8 squared equals, actually you do have to know 5 squared is A. Actually you don't. It's kind of okay. But it is A because it's the good access value. But plus, even if you made them and switched them, you'd still get the correct answer at the end. This is 25, 64 minus 25, 54, 44, 39? Is that right? Nobody asks. No, nobody says a word. Everyone's just staring at me like I get no help whatsoever. It's so funny. Is it 39? Anyone calculated it all? So tough being a teacher. Students are getting less and less connected because those phones making them robots, controlling their lives. It's true. All right. Yet again, I got to divide by 36. I'll stop and take a breath. Not really mad at me because I said robots and I offended their phone. Alrighty, nice little break there. Thought something was going to happen there. 4 into 36 is 9, right? And then 9 into 36 is 4. Okay, and this one, the last one, A was smaller than B, and this one, A is bigger. Good axis. Good, good, good. I'm going up and down. So the y-axis radius is 3. And so I go 3, -3, and I do make those dots. X-axis radius, these are not points on it, but they help make the box. And then instead of an ellipse, I make a box because this is a hyperbola because there's minus. Very simple. Very simple, simple stuff. And then this goes up and down because the good axis is the y-axis. Ain't no thing, chicken wings. And those are asymptotes, our word for the day. And then just one more mathematical thing to do. C squared equals 9 plus 4. And then you square roots. And just hold that number. I guess I'll do it all the way around. Square root of 13. Okay, what's the square root of 13? Square root of 9 is 3. Square root of 13 is 3 point something. So it's a little bit above. And I can barely draw it because I made my big, look at how big I made those dots and I missed them. So it's kind of hard to draw those. I kind of snuck them in there. All right, but they're just barely there. And I noticed the hyperbola is a little bit skinnier. So there's a thing about that. Oh, I forgot to do eccentricity. My bad, dogs. Roof. Go back to 2 examples ago, and I want to just show you that eccentricity for a hyperbola is higher than 1. And you got to be careful on this. A is the good axis, not the bigger of the 2 radii. So A is 2, C over A. Eccentricity is still C over A. And then, of course, square root of 5 is way bigger than 1. Not way bigger, but it's bigger. Eccentricity will always be over 1 for a hyperbola. Remember what I told you about the space example there. All right, let's just do the vertices. Verts are 0, comma, plus or minus 3. Foci are going up and down. So it's 0, comma, plus or minus root 13. Asymptotes, here we go. Rise, overrun, because I do have to get to completing the square. Rise 3, run 2. So it's y equals plus or minus 3 over 2x. Don't be doing a's and b's. It's y-axis radius divided by x-axis radius. That's what rise over run is. And then real quick on eccentricity, it's root 13 over 3. All right, 3 is A because it's the good axis radius value. Now I got to get to our last question, and I'll hold it there for a second as people catch up with my writing because I did that really, really fast. Right in the compass, right? Ooh, and then my lunch. I'm hungry. Makes me feel good in my throat as I eat. Boom shakalaka. First of all, why is this not a parabola? Because we're going to have a day of completing the square only, and it's probably going to be Tuesday next week. Why is this not a parabola? Go ahead. Say that one more time. No, I said, why is it not a parabola? I threw that out there. There's 2 squared. Why is it a hyperbola? Now you say what you said. There's a negative. This is automatically, no matter what, a hyperbola because one of the square terms are negative. So you are guaranteed to have a minus sign in between these when you're done completing the square. 100% true. But I threw that out there. Parabolas stick out like a sore thumb. There's only one square term. This could be a circle because the numbers are different. I didn't even ask that of myself. As soon as I see one of them is negative, automatically hyperbola. And it actually is very similar to what you had to do with an ellipse to complete the square. Group these in your head and pull out a 12. Same starts. Not a big deal. This is actually, you have the math and know how to do this. And then put your blank. Here's the difference. No pun intended again. You don't pull out a 4. You have to pull out a negative 4. This must be 1y squared on the inside of the parentheses in order for you to complete the square. So plus negative 4 is pulled out, or a negative 4 is pulled out. And then 4 times 4 is 16, and it's a positive 4. Whatever you do to one side, say it. So it's negative 4. I'm not doing the 3-second thing today, I guess. And then I got to put my blanks here because I'm out of room. Whatever you do to one side, you do the other. So I put those blanks here. What's the first blank? 3, 2, 1, go. Oh my gosh, you guys are killing me. I'm going to do it one more time. What's the first blank? 3, 2, 1, go. 9. Arr. What's the second blank? 3, 2, 1, go. 4. Careful. Give you a chance to calculate this. Hint, hint. What's the third blank? 3, 2, 1, go. Oh, I didn't hear a lot of 108s. Did anyone say 108? 9 times 10 is 90. 9 times 2 is 18. 90 plus 18 is 108. You said it? Nice. Nor, you made the video. And then what's the last blank? 3, 2, 1, go. Everyone better get that one. Negative 16. Completing the square is actually fast. I'm not teaching factoring. I'm done. I'm done with you. I'm done. Instead of watching, hey, did you see that monkey playing with that cat video on TikTok? Yeah, let's look at that for 7 hours instead of a factoring video so that maybe I can pass Mr. Samuelson's tests. Arr! That's how I feel about this. Google factoring, enter, blah, 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 a million videos. You don't even have to listen to me. You can watch somebody else do it and figure it out. I think it's 48. I did that from last hour. Does anyone want to check? Is that right? Whatever. Divide by 48. Parents, you should know this too. Your students never have had more at their fingertips to get help ever in the history of humankind. Ever. Even here, we got so many things out there. I have a compass thing. I think I have 3 students in this class that's ever signed up for Compass to get help. Ever. On their own. And I'll end with that.